to my channel, Michelle Gay Science Teacher. Today we are talking about volcanoes. Oh my goodness, who doesn't like to learn about volcanoes? Volcanoes can be so mysterious, but yet scientists have figured out so many things about volcanoes that we can learn and experience as young children and as adults. Today, when we look at volcanoes, we're going to look at three types and how they're formed. We're going to look at the composite, we're going to look at the shield volcano, and the cinder cone volcano. These three volcanoes were formed differently because of viscosity. What is viscosity, I bet you're saying? Well, viscosity, it is basically just how thick a liquid is. If it has high velocity, that means that that liquid is thick and it's going to run slow. If it has low viscosity, let's say like water, then it is going to run faster. Look at this demonstration. I have syrup, chocolate, and honey. Notice how fast the syrup is moving, but yet look how slow the chocolate is running. That means the chocolate has a higher viscosity than the honey or the syrup. Well, when volcanoes form, they form based on the viscosity of the lava. Lava is what comes up from the magma chamber and it flows out. Well, it flows out at different rates and it flows out at different speeds, and that way when it begins to hit on the outside, those volcanoes begin to form differently. Notice that the composite volcano, it is much higher. This is the one we usually like to see. We see it on movies, we see it in videos, when kids make them for projects. This is the one they want to make because it's high and it's steep. But then we have what we call the shield. The shield is a lower volcano, but it spreads way out and because of the way the lava comes out. And then, of course, the cylinder cone, it has a big bowl opening and it is much wider and different than the other two. What we're going to do next, we're going to explore. We're going to first talk about the composite, and we're going to see how the lava flows by using just some chemical reactions of baking soda and vinegar, and we want to see how it flows on the outside of the volcano. This is our composite. It has a cone shape with a branch vent. So we have our major vent right here, but it also has a branch vent on the real one to the side, meaning that the lava can flow from two different places. Now, when this happens, it has a high viscosity. So because it has a high viscosity, that means that when the lava comes up from the magma chamber, it is going to flow slowly. And because it flows slowly, it begins to harden and build up. And as it builds up, it becomes the highest volcano that there is. All right, let's look at this and see. Now, usually this one explodes because it has that other crater that's to the side. Remember, this is our crater here in the middle. And so it has that other crater, and sometimes it gets clogged and it just explodes. So what we're going to do, we're going to pour in some baking soda, some dishwashing liquid. Let's see if this will work. And let's put some food drop colors. And vinegar. Now, if you decide to do this at home, remember safety first. You need safety goggles and you need adult supervision, or even if you're doing it at school. Let's see. All right. Here we go. It's flowing out. And notice, you see, it's going down all through here. And these layers begin to build. And so we have this lava flow slowly moving down, and it's building up our composite volcano. So it's catching here in the rims. Look at all the cracks where it's going through. Observe it closely. And so we said this has a high viscosity. And because it has a high viscosity, it runs slowly. And because it was running slowly, it hardened. And as it hardened, it continues to stack up on top of each other and build. Now we have the shield volcano. The shield volcano is the largest volcano. It spreads way out, and it's called a shield because they say it kind of looks like a Roman shield. It has one major crater in the middle here, and that's where the lava flows out. But with this volcano, it has a low viscosity. Remember, if it's a low viscosity, that means that the lava is going to be thinner and that it is going to run faster. And because it runs faster and way out, it begins to spread out quickly and it begins to form, and that's why it looks this way. These type of volcanoes are really famous in Hawaii. All right, so let's see. We're going to test this one out. We're going to put our baking soda in. Let's use red this time. And let's see. All right, let's try this one out. Here we go. See how fast that's going? And it's spreading out all over the table. Look how fast, because it's going fast, it's spreading and spreading. That's because the viscosity is thinner, and when the lava comes out, it begins to spread and go way out and build a wider volcano. Notice how it goes through all the areas, all the cracks, and it just slides right on down because it is a thinner viscosity. All right, we have one more to look at, and we're going to look at the cylinder cone. This is the cylinder cone. The cylinder cone has one crater, open vent, and it's a bowl-shaped open vent. This one is larger than the composite, the one that we're used to. With this one, the lava flows out quickly, and when it flows out, it shoots up, and when it shoots up in the air, it begins to form tiny rocks and cinders. That is because the lava has gas in it. And so when you think of gas, you think of bubbles. And so when it comes out, it spreads out, and then when it lands back, it has all these tiny rocks that have built up around it. We're going to test this one out next. Now it has this bowl shape, meaning it is a bigger opening. Let's put in yellow. All right, I'm going to add just a tiny bit more. Okay, and here we go. Let's see what happens. See how that shoots out? And it actually goes up in the air even higher. And notice how it flows, but when it comes back down, actually, guys, it is actually come back as cinders and tiny rocks. So we've looked at 3 different volcanoes. Remember, we have the shield, the composite, and of course, this is our cinder cone. Volcanoes are formed based on the flow of the lava. Remember viscosity? Viscosity is how thick or thin the liquid is, basically how thick it is. And if it runs slowly, that means it has a high viscosity. If it runs fast, that means it has a low viscosity. All right, so now that you know about these 3 volcanoes and how they're actually formed based on viscosity, I want you to test it out at home. I simply made these 3 volcanoes using just a tin pan, balled up some paper, put foil on top and a cup in the middle. And then you will just need some simple ingredients like vinegar, baking soda, some type of dishwashing liquid, and food coloring. Remember, safety is always first, guys. All right, I hope you enjoyed this video, and I hope you go and make a volcano and test out the viscosity to see how fast a volcano can form. Thanks, guys. See you in my next video.